we discuss about gravitation chapter short note. Newton's law of gravitation. M1 M2 distance between r, force of attraction between 2 point masses F is equal to G M1 M2 upon r square, directed along the line joining of the point masses. It is a conservative force field is equal to mechanical energy is conserved. It is central force field. Angular momentum is conserved. G is equal to 6.67 into 10 ke power minus 11 meter cube upon kg second square. Gravitational field due to point mass at distance x. Eg is equal to gm upon r square radial inward. Gravitational field on the axis of uniform thin ring at distance x. Eg is equal to gm upon in bracket r capital R square plus x square whole to power 3 upon 2 x. Eg is maximum at x is equal to plus minus r upon under root 2 uniform linear mass density lambda. Eg y is equal to g lambda upon x in bracket cos beta minus cos alpha in bracket. Eg x is equal to g lambda upon x in bracket sin alpha minus sin beta. Gravitational field due to a spherical cell outside the cell. Eg is equal to gm upon r square, where a small r is greater than capital R on the surface. Eg is equal to gm upon r square, small r square, where a small r is equal to capital R inside the cell. Eg is equal to 0, where capital R is greater than a small r. Directions always towards the center of the sphere. Gravitational field due to solid sphere. E a small r is equal to capital R, small r, I is directly proportional r outside the sphere. Eg is equal to gm upon a small r, where a small r is greater than capital R on the surface. Eg is equal to capital Gm upon a small r square, where r is equal to capital R inside the sphere. Eg is equal to gm r upon r cube, gm r upon capital R cube, where capital R is greater than a small r. Acceleration due to gravity. G is equal to gm upon r square at height h. Gh is equal to gm upon in bracket r plus h ke whole square. If h is smaller than r, then gh is equal to gs in bracket 1 minus 2h upon r. Or depth d is to gd is equal to in bracket gm in bracket r minus d upon r cube, gs in bracket 1 minus d upon r. Effect of rotations on g is to g1 is equal to g minus omega square r cos square lambda, where lambda is angle of latitude. Gravitational potential due to a point mass at distance v is equal to minus gm upon r. Gravitational potential due to a spherical cell outside the cell, v is equal to minus gm upon r, a small r greater than capital R inside. On the surface the cell, v is equal to minus gm upon r, a small r is smaller than capital R. Potential due to solid sphere outside the sphere B is equal to minus Gm upon R. Small r greater than capital R on the surface B is equal to minus capital Gm upon capital R. R is equal to small r is equal to capital R. Inside the sphere B is equal to minus Gm in bracket 3 r square minus r square upon 2 r cube. Capital R is greater than small r. Potential on the axis of a thin ring at a distance x is equal to V is equal to minus Gm upon under root capital R square plus x square under root capital R square plus x square. Electrostatic self energy for 2-point masses U is equal to minus G m1 m2 upon R. Uniform thin spherical shell U is equal to minus Gm square upon 2R. Uniform solid sphere is equal to U sphere U is equal to 3 upon 2 Gm square upon R. Escape velocity from the surface of planet of mass m, radius capital R, Ve is equal to under root 2 capital Gm upon capital R. Now orbital velocity of satellite V0 is equal to under root capital Gm upon small r is equal to under root capital Gm upon in bracket capital R plus H. For nearby satellite V0 is equal to under root capital Gm upon R is equal to Ve upon under root 2 Be escape velocity on Earth's surface.